Hey guys, in this session we're going to be looking at how to find values of k for different points of intersection, mainly used in systems of equations at level 2. You probably find it somewhere else as well, but anyway, this question kind of popped up today and a couple of people have been asking me to kind of work on it, so here goes. Basically what I've done is I've just taken one of the questions that a student actually sent me, and what we've got here is a straight line and we've got a circle, and I think the question, when I had a look at it, she said that find values of k for, so that there's like 2 solutions, but I'm going to show you guys all 3 of them, so the 3 situations that could happen. Really good thing to kind of learn before attempting this is have a look at some of my discriminant work at level 2 algebra, or even if you have a look at like the live tutorials that I've done for discriminants, it'll be quite handy to understand what's actually happening here. So what we're going to do is I'm going to kind of do something slightly different here. So I'm just going to see if I can shift over to my main screen, which I had here, but it's now gone. Let's try this. There we go. Cool. So what I've done is I've actually kind of put both of these equations in Desmos, just so that we can actually have a look at what happens when k is actually of different values. Now obviously looking at that first equation, that's actually a straight line, and then if you look at the x squared plus y squared, that's just a circle. Now when k is equal to 0, you can clearly see that there are actually two solutions here, right? But what happens as we move k? Now at some point here, like let's see, around there, maybe 10.2, I'm just going to roughly guess it here because I know I might be off. Again, I'm not really accurate, but you get the idea, right? Somewhere between 10.2 and 10.1, there is an intersection like this. It's where the red line is like touching the green circle, right? Then if we go the other way as well, so let's say I bring it down, so that's going to be minus, yeah, around minus 10.1, you've got another point of intersection. No, I just went too much. Let's try 10.1. There we go, roughly there, right? I mean, this is just an estimation. But if the value is actually greater than 10, you can kind of see that there's actually no solutions, or when it's actually less than negative 10, there's actually no solutions. So what we're going to try and do now is we are going to actually show this algebraically. Once we show this algebraically, then I'll go back to the diagram and it should kind of make sense what we're trying to actually solve here. So I guess the first thing we're going to have to try and do is, you know, we've got 2 equations here. One is a straight line, one is a quadratic. We've got to get rid of one of these elements, right? So and the easiest one to always do is to get rid of like rearrange the straight line equation with y as the subject. So I'm going to take this and I'm going to rewrite this as 8y equals k plus 6x, but I could just write that as 6x in the front there, and I've got 6x plus k. Then I can rewrite this as y is equal to 6x plus k, and the whole thing is actually divided by 8. Now with your fractions, remember that you can actually switch through that. Like you can actually rewrite this as y is equal to 6x over 8 plus k over 8. Now here's the issue, right? So what I'm going to be doing is I'm going to take this y, which is 6x over 8 plus k over 8, and I have to actually substitute it with the y in the quadratic equation. Now that's going to be quite tricky. I mean, and I hate dealing with fractions, I'm not going to lie, right? Sometimes I enjoy it, but when it comes to quadratic and like expanding it out, as long as it's not a recurring decimal, I would say you can actually work with the decimals. Like in this case, we know that 6 over 8 is actually 0.75, and just in case, you know, if you're like, how the hell did you get that? There we go, 0.75x plus, we've got 1 over 8. 1 over 8 is going to be 0.125. And we're going to leave that k as it is. Cool. So this is our first step that we want to do. So what we've literally done here is rearranged y in terms of x and k. So the next step is to substitute y. So we've got x squared plus y squared is equal to 1. So we can rewrite this now as x squared plus, well, because we know that y is that really ugly looking equation down there, we're going to rewrite this as 0.75x plus 0.125k squared equals to 1. So at this point, what we need to do is we actually need to expand this quadratic. And because we're going to expand it, I always just write the two brackets next to each other, just because it makes it easy for me. So I'm going to put down 0. See what I mean by, I can see that mistake, 0.125k multiplied by 0.5x plus 0.125k, and all of that is actually equal to 1. So let's give ourselves a little bit of space here. And what we've got here is x squared plus, now we got 0.75 times 0.75, so just as the first lot that I'm going to be working out, so 0.75 times 0.75, that's 0.5625, so 0.5625 x squared. Then I've got 0.75 times 0.125, 0.125, that's giving me 0. Plus 0.09375, and then we've got x and k. And of course, when we repeat that, we're going to get another one of these things, so 0.09375 xk. And then finally we've got plus, I'm going to write that in the next line, guys, I'm sorry, no, let's do it this way then. There we go, let's do that. So the last one was 0.125 times 0.125, which gives us that ugly number, 15625 k squared. And now I'm thinking this might actually would have been better with, what do you call it? Better with fractions. It might be better with fractions, but it's alright, you know what, it doesn't really matter. We're going to leave this like this. What's our next thing that we can do? We can actually combine these two terms together. So when we do that, we're going to get x squared plus 0.5625 x squared. And now these two numbers that are combined, so we've got 2 times 0.09375, which is 0.1875 x and k, plus 0.05625 k squared. And I'm going to bring that minus the 1 back to the left-hand side. So it will actually become minus 1. And now all of this is equal to 0. Cool. Now this is the ugly equation that we're going to work out the discriminant from, right? So basically, remember that your discriminant is actually ax squared plus bx plus c is 0. Like, that's your quadratic equation. And then once we get from there, we got to get the a, b, c. Then we can actually apply the discriminant formula and kind of like work it out, right? So let's see what are all the coefficients of x squared. Now we've got a coefficient of x squared which is right there, which is equal to 1. And then we've got 0.5625. So straight away I could write down here that a is equal to 1.5625. Now remember, this is actually 1x squared. That's where that 1.5625 is coming from. Our next thing is looking at the coefficient of x, which is going to be b. Now the coefficient of x happens to be 0.1875, but it also includes the k. That's something that you guys need to remember, right? Because it's everything in front of x. So we don't look at the x, but we look at everything surrounding it. So in this case, what we then have is we've actually got b is equal to 0.1875k. And finally, we've got to look for the value of c, which is just the numbers by itself without any x's. So in this case, this entire thing right here is going to become C. So we're going to write this as C is equal to 0.015625 k squared. Of course, minus 1. Jeez, see, I know I was going to make that mistake. Cool. Now that we've got our ABC, we can actually work out what our discriminant is. Because remember, our discriminant is b squared minus 4ac. Now, in this particular question that the student sent me, they wanted two solutions, right? Because they wanted two solutions, like 2 points of intersection. Now, that means the discriminant has to be greater than 0. So, as I said to you guys before, have a look at the discriminant tutorial that I've done before. Otherwise, what you have here is if b squared minus 4ac is like bigger than 0, then b squared minus 4ac is equal to 0. B squared minus 4ac is less than 0. So this is the kind of situation where we have two solutions, one solution, no solution. Okay, so we're going to do the first one, which is the two solutions, right? So all I've got to do here is I've got to write down b squared minus 4ac is greater than 0. Now this might require a little bit more room, but I'm going to try my best to try and fit everything in here. So I know that my b value is, what do we got? So there is my b value right there. So I'm just going to kind of highlight it there. So that's where I'm going to substitute b from. My a value is this. So there's my a value. And finally, my c value, which is all of this, is going to get substituted there. So let's substitute this. So we've got b, which is 0.1875 k squared. No, sorry, k bracket squared minus 4 times a, which is 1.5625, multiplied by c, which is 0.015625 k squared minus 1. Okay, and all of this has to be greater than 0. So let's get that out first. Now we've got this ugly thing we've got to try and solve. So I've got 0.1875 times 0.1875, which is equal to that. Now here I'm thinking, it's like, God, this is so annoying to do, right? Like write this many decimal things. So what you can do is like go to the calculator and just click on that F to D button right there. All right, that just makes things slightly easier for you to write down. It's just kind of like being lazy, but like, you know, you can do that as well. So 9 over 256. I'm going to use that, right? Because it's easier. So I've got 9k squared, because k times k is k squared, over 256. Now I'm thinking, as I said to you, like I think it's easier to do it by fractions, but it's all right. We're going to do this. So we got 4 times 1.526, or did I copy that wrong? No, it is right. So I've got 4 multiplied by 1.5625, 6.25, or if I put that as fraction, I'm going to get 25 over 4. Let me just put that outside there, right? 25 over 4. And that's multiplied by, what's that? Let's try that out. So we're going to put 0.015625. What is that as a fraction? As a fraction, that's 1 over 64. Might as well use that. 1 over 64, k squared minus 1. All of that is greater than 0. Now you might be wondering, why did I switch over to fractions when I started with decimals, right? Well, look, initially decimals was easier to write, but then after that, kind of like I realized maybe I shouldn't have gone with decimals because they're just going to get ugly. Maybe it might be better with fractions, but you know, it doesn't, unless you do it, you're not going to know. All right, so we're going to expand the brackets here. So we've got 9k squared over 256 minus 25 over times k squared in the numerator. That's going to be 25k squared divided by 4 times 64, which happens to be 256. Negative 25 over, so basically what I'm doing is I'm like expanding the brackets, so that's what I'm doing here. So negative times negative, that's going to be positive 25 over 4, and all of this is greater than 0. Okay, so let's kind of rearrange this and let's hope this actually is going to work out, because it's going to be super annoying if it doesn't. So 9 minus 25, that's negative 16k squared over 256 plus 25 over 4 is greater than 0. So what I'm going to do is, let's make things a little bit, I'm just trying to see a couple of ways of doing this so that you guys can get the answer straight away. Okay, so what I'm going to do is I'm going to show you guys a couple of ways of doing this. The first method I'm going to show is purely by algebraic methods, just to show you guys how to rearrange things. But the second method I'm going to show you in the graphics calculator as well. So in the graphics calculator, we're going into graph, and under the graph function, we're going to put this equation. So we've got negative 16, and instead of k, we're going to go x squared divided by 256, and then we're going to go plus 25 over 4. There we go, and we're going to draw it. Now right now I can't actually see my graph where it is, right? And this is the annoying part about graphics calculators, because sometimes you can't actually see your graphs. However, there is one thing that you can do, and I hope it actually works. You can actually click on Gsolve and look at something called roots, because this is when the parabola is actually touching the x-axis. So if I click on it, right now it says no fun. Yeah, it's just wonderful, isn't it? So here's where sometimes it, like, you might have to like go zoom out quite a bit. Oh, there we go. We got two solutions right there. Let's see if this works right now. Shift root. There we go. See how that's coming out as x is equal to negative 10. And then if we look at the other root, x is equal to positive 10. So basically, we're looking at when is this parabola going to be bigger than 0. Because if you think about it, we did this at level 1 quite a few times. So what we have here is we've got a quadratic equation that, because of this minus right here, we know that we're dealing with a negative parabola. We found out what the two roots are, which happens to be negative 10 and positive 10. And that's the x-axis right there. This right there is telling us that we're looking for greater than 0, which means like we're going to be above 0. All right. Basically, what this is telling me is that if k is between negative 10 and positive 10, then you're actually going to have two solutions. All right. Now we're going to confirm that. We just want to confirm that in the other diagram, unless I made a mistake here somewhere. It's possible. Let's go back here and have a look. So I'm talking about here, right? Now remember, if we put it negative 10, I think at negative 10 it's equal, so that means there's going to be one solution. So if I zoom right in right there, is there a point? There we go. But it's like at negative 10, there's actually it's actually touching, the red line is touching the green circle, right? Which means you got one intersection point. But the moment it goes less than negative 10, so let's say we go to negative 9.999, you actually should have two solutions, theoretically. If I zoom in, please tell me there's two solutions. There we go. You see what I mean by? So when you actually zoom right in, you're going to end up with two solutions. So that's the difference between negative 9 and negative 10. Because look at this. If I change this to 10, to negative 10, I missed it. Where is it? There. It has one solution. All right. So when k is equal to negative 10 or positive 10, you're going to have one solution. But anything between negative 10 and positive 10, you're going to have two solutions. So let's say if I go, what's a number between 10 and negative 10? Well, let's say 5, right? Okay, so let's go to 5. And I'm going to zoom out right there. You can kind of see it, right? At 5, you've got like two solutions. But the moment we come to 10, we're going to have only one solution. So if I go back to my notes right here, notice how I have actually written it this way. Because those two arrows are actually telling that when we actually have, when it's actually less than and greater than, it's not actually including 10. So when it doesn't include 10, it's going to actually have, and it's when it's between negative 10 and positive 10, you're looking at two solutions. So that's what that discriminant with when it's actually greater than 0 looks like. Now I want to show you guys what equals to 0 looks like, because it'll kind of make sense when I try to do this. Let's try that again. And let's move that there. Okay, so this is what we just did, was for two solutions, right? Now if we want one solution, we can actually use the same graph, because for one solution it's just looking when this equation is actually equal to 0. So I'm still going to get the same equation, but I'm going to get negative 16k squared over 256 plus 25 over 4. And remember, discriminant has to equal to 0, which means when it equals to 0, that's the two roots that we're talking about. So in this case, we can say that if k equals to positive 10 or negative 10, you're actually going to have one solution or one point of intersection. All right, so I'm just trying to cover like all three scenarios here for you guys. So this is one solution. And when it's actually less than 0, I'm going to go back to this diagram that I drew here. Where is it? This is that the one I did earlier with, and we still know the 2 points are still going to be negative 10 and positive 10. But when we're looking for the discriminant when it's actually less than 0, so that's when it's b squared minus 4ac has to be negative. When the discriminant is negative, you're actually going to have no solutions. Now in this case, these are the two little areas that we were looking at where it's actually in the negative zone, right? So we can rewrite this as when k is less than negative 10, and then when k is actually greater than positive 10, we're actually going to have no solutions at all. So if I go back and show you guys that, when k is greater than 10, so if you look at it, when k is bigger than 10, the red line is not touching the green circle at all. And when k is less than negative 10, again, it's not touching, the red line is actually not touching the green circle at all. So there's like key important things, right? So not touching. At 10, it's touching it once. Let me just kind of do something here so I can make it a little bit easy. Yeah, that's better. So we can kind of see at 10, it's going to be touching it once, negative 10, sorry, and then between negative 10 and positive 10, it's kind of like having multiple solutions, but then once it gets to positive 10, one solution, bigger than positive 10, no solutions. All right, so I know this was an extremely kind of like a long video here, but this video here will help you guys not just with systems of equations, but later on when you're dealing with discriminants in algebra, you're going to have to come back to this again, this same theory, like this whole drawing a parabola and finding out when the discriminant is positive and negative. Super handy skill to kind of have throughout level 2 algebra, or if you're doing level 2 maths, and if you're doing algebra and calculus, this is something that's just going to keep repeating itself again and again in so many different formats. So as I said to you guys before, like, I started with a, in hindsight, maybe doing fractions might have been easier. That would have avoided writing those long decimal points. But I guess I kind of learned my mistake as I went through it. I realized, okay, maybe this questions might be easier to work with fractions after all. So still, nothing changes when you're doing with fractions. Pretty much the kind of like the same idea. Like if you have fractions and you want to do square of like 6 over 8 times 6 over 8, just chuck it in the calculator, guys. So just go into menu, go into your normal calculator, 6 over 8. Wait, what do we got? 6 over 8. Yeah, and just go times 6 over 8. Just simpler to do it like that as well. And like I said to you guys, if you ever have like really complex looking decimals and you're like, oh man, I don't really want to write this decimal, just type it in the calculator and click on the F to D button to convert it. All right, so I'm looking at 0.015625. I think it's one of the C values there, right? If I click on equals and then click on F to D, I got 1 over 64. That's my fractions right there to convert it into a fraction. Good, guys. Yeah, I think that's pretty much it for this video. And like always, if you have any questions or comments, drop it in the comment section below. And when you do have any questions, and if I get some time, yeah, I kind of can spend some time doing something like this. But apart from that, yeah, catch you later. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.